Hey, fifth grade, Ms. Kachibata here. All right, we are going to go ahead and get started. Thursday, April 9th, 2020, that is today. Our joke of the day, why did the Oreo go to the dentist? To get his filling. Ha ha ha. Okay, so it's me. Whoops, nope, that's not what I wanted. Sorry, guys. Let me switch over. Fifth grade. All right. They have messed up on some of these pages. This is not week 4, it's week 3. So week 3, lesson 4, this is where we should be. So our objective for today is I can solve word problems involving addition and subtraction of fractions. All right, so for our fluency today, we're going to show the fractions on the strips and then add them and write the sum. All right, so let's see. All right, so I can see in our example that they took 2/4. They divided these tape diagrams that are divided into eighths, and they divided them equally into 4 groups and then shaded in 2. They did the same thing when they had the second fraction 3/4. They divided them up into groups of 2, and then they shaded in 3 of those 4 groups, and then they put them together, and they came up with their answer, which is 1 1/4. Right, so we're basically going to do the same thing. So they kind of drew darker lines, but just so that we can see, this says, let's start an A here, and it says 3/4, but I know that my tape diagram is in eighths, so I really want to make it obvious that I'm going to divide them into fourths. So I'm just going to draw darker, bigger lines to divide this tape diagram into fourths. So I've put them into I've put them into groups of 2, but now I have 4 groups, right? This is a group, 1 group, 2 groups, 3 groups, 4 groups, okay? So now I have them in fourths, all right? And I'm going to shade in 3 of those, okay? So I am going to shade in 1 group, 2 groups, and 3 groups, right? So now I've shaded in 3/4, okay? All right, now I'm going to do the same thing over on the next one, okay? I'm going to divide this into fourths. Whoops, it's very hard to do this. And you guys already know that I'm not good at drawing and stuff. All right, so 3/4. So again, I am going to shade in 3 of them. Dang it, other color. All right, there. Now I've shaded in 3 groups of 2, all right? And now I'm going to add them together. So again, this really helps me. If you don't need to draw these big lines, that's fine. But I like the added visual. So now I'm gonna shade in, I should have done these in 2 colors, but I didn't think about it. So I'm gonna shade in the first ones, 1, 2, 3/4. And now I'm not going to go to the second tape diagram. I'm just going to keep going, but I'm going to do the other 3/4. So 1, 2, 3/4. All right. So now I'm going to add those up all together. So I know that here I have 1 whole, right? Because I've shaded in this one thing. And now here I have 2/4. All right. So this is going to give me the fraction 1 2/4. Which we know is the same as 1 1/2. All right. So going on to my next one, going on to B, this time I will be smart and I will use 2 different colors. So the first one says 3/8. So I don't have to split this up into fourths because I'm using eighths and there are 8 units in my tape diagram already. So I'm going to say, okay, I'm going to color in 3 of these, 1, 2, and 3. All right. Now over here, I'm going to shade in 1/2, and I know that 1/2, if I'm thinking of eighths, that's the same as 4/8, right? So I'm going to shade in 4, 1, 2, 3, and 4. All right, and now I'm going to put them together on my tape diagram. So I'm going to start with my 3/8, 1, 2, 3, and then I'm going to shade in my 4/8. 1, 2, 3, 4. All right. Now I'm going to count up how much do I have altogether. I can see that it's less than 1 whole. And here I have 7/8. Whoops. 7/8. So when I go over to my fraction, what is the sum of 3/8 and 1/2? I'm going to write that it is 7/8. Okay. Going down to C, I have 5/8. So again, I don't need to split up these pieces. All right, so I'm going to say, all right, 5/8. I'm going to color in 5 pieces. 1, 2, 3, 4, 5. All right, that shows 5/8. Then I'm going to color in 3/4. So again, we can divide this into fourths to make it easier. All right, now if I color in 3 of these fourths, right, I have this one, this one, this one, that's 3/4. Now, to make this easier to add together, I want to know, okay, how many eighths did I shade in? How many individual units? So 1, 2, 3, 4, 5, 6. I shaded in 6/8, okay? So now this is going to help me when I put these two together because I'm going to start with my 5/8. 1, 2, 3, 4, 5. And now I'm going to shade in my 6/8, right, which is 3/4. So I'm going to shade in 1, 2, 3, 4, 5, 6. All right. Now together, again, this is going to give me 1 whole and 1, 2, 3, 3/8. All right. 1 whole and 3/8. Do you see how that visual really helps you? It makes it a lot easier to see, the equivalent fractions and to add fractions with 2 different denominators without having to use the multiplication and create equivalent fractions. Okay? So go ahead and take a minute, finish that up, make any corrections. All right, and then we will move on to our daily task. It says, for each of the following word problems, determine whether or not the expression 2/5 plus 3/10 represents the problem. Explain your decision. Okay, so remember, we are looking at this and we need to decide, okay, does 2/5 plus 3/10 match this word problem? So let's read our word problem. A farmer planted 2/5 of his 40 acres in corn and another 3/10 of his land in wheat. Taken together, which is a very important part, right? Taken together in all, what fraction of the 40 acres had been planted in corn or wheat? So I want to think, okay, 2/5 of the 40 acres were in corn, right? 2/5. And the 3/10 of that same land, that same 40 acres, is wheat. And the question asked me what fraction specifically, what fraction of the 40 acres had been planted in corn or wheat, right? So I can see, just looking at my tape diagram too, and after I've really read that problem and, thought about, okay, how would I solve this? What is it asking me? What language is it using? I know that this does make sense, right? I would say, okay, 2/5 of the acres plus 3/10 of the acres, because it asked me what fraction had been planted altogether. All right. So yes, you could use this expression for this problem. So for this response, all right, it's not asking you to solve it. It's just asking you to say whether or not you would use this. So yes, this expression represents the problem. And then you're going to fill this in because why? What did we just talk about? Because, then go into what is the question asking. It's asking us to find the total fraction of the land that had been planted, right? Okay, so once you have finished with that, go ahead and scroll on down. Okay, and again, we're trying to figure out, can I use 2/5 plus 3/10 to represent this problem. All right. So, okay. So this says Jim drank 2/5 of his water bottle and John drank 3/10 of his water bottle. How much water did both boys drink? Okay, so this doesn't have to be like a super perfect math model when you're drawing this out to decide. It can be whatever helps you. So I'm going to draw a picture that helps me. So I'm thinking, okay, Jim has a water bottle, right? Here is his, let's see, Jim. Here is his water bottle, okay? And he drinks 2/5 of it. I'm just guessing. I don't know if that's actually 2/5. I'm guessing, okay? Then I have John. And he has his water bottle. Okay, and he drank 3/10 of it. And again, I'm not really measuring this out. I'm just guessing 3/10. Okay? Now, we want to know how much water both boys drink. So I want to think, again, if I were to solve this problem, what do I know and what do I not know? Okay? So I know how much of each water bottle they drink, right? Jim drank 2/5 of his and John drank 3/10 of his. But here's what I don't know. I don't know how much water is in Jim's bottle and how much water is in John's bottle. I have no idea. What size water bottle do they have? I don't know. Jim's could be a tiny, normal water bottle, and John's could be one of those big gallon jugs that you see some of your teachers have at school, right? All right? I have no idea how much water is in their bottles. So let's pay attention to the question, because remember, the question's asking me how much water did both of the boys drink. This isn't like our last problem where it said what fraction of their water bottle, like what fraction of the water did both boys drink, right? It's not asking me that. It's asking me specifically how much water. Well, first of all, I don't know what we're even measuring their water in. Are their water bottles measured in ounces or gallons or liters? What are they measuring their water in, and how much water did they start with? I don't know. Maybe John started with 2 gallons, and maybe Jim started with 4 cups, right? I have no idea how much water is in their water bottles. So I cannot use 2/5 plus 3/10 to solve this problem, right? I have no idea. If, it had told us how much was in each water bottle, then we could use that right? Thinking of multiplication, we could use the, he drank 2/5 of, 30 cups of water, or whatever. He drank 2/5 of 25 ounces of water. And then we could figure out how many ounces, but we have no idea. It didn't give us enough information. So the answer here is no. We cannot use this expression, 2/5 plus 3/10, to solve this problem. Okay, so again, down at the bottom, you would write no, because, and then again, going into everything it didn't tell us, because we don't know the size of their water bottles or how much water is in each bottle, right? Or because there's not enough information, or, no, because the final question didn't ask us what fraction of the water bottles did they drink. It's asking us how much water, right? So, again, using those complete sentences in your own words. It doesn't have to be perfect. You don't have to say it exactly like I did, as long as you're using those mathematical terms, and also going back and being very specific. I don't want to see, no, you can't. Okay, well, why can't you use this? And, I don't want to see, no, you can't because it doesn't make sense. Okay, again, remember, we have to explain our thinking. Why doesn't it make sense? Why can't we use this expression? Okay. So, moving on down to the next one. Again, I just keep writing it to help me so I remember what I'm doing, basically, because I'm very forgetful. You guys know that. Okay, Allison has a batch of eggs in the incubator. On Monday, 2/5 of the eggs hatched. Okay? And by Wednesday, 3/10 more of the original batch hatched. How many eggs hatched in all? Okay, so again, I'm going to think, I'm going to draw a picture, or just think out loud, whatever you can do, draw something out that helps me. So I know that I have an incubator of eggs. Okay, here are my eggs. I know that on Monday, 2/5 of the total hatched. Okay. By Wednesday, 3/10 more of the original total hatched, not of what's left. Okay. How many eggs hatched in all? The question is, how many eggs? Okay. Again, I noticed that it wants the concrete number of eggs. It's not saying what fraction of eggs hatched. It's saying how many eggs. Okay. So again, I'm seeing those words of, right? Which, especially if it's saying 2/5 of, 40 eggs or 3/10 of 40 eggs, right? And we know then we would multiply to figure out how many eggs. But I'm noticing that it didn't tell me how many eggs I started with, right? I have no idea how many eggs are in the incubator. It just says a batch. Well, how much is a batch? That's not something like saying a dozen, right? We know that there are 12 in a dozen, but we don't know how many are in a batch, right? You could make a batch of cookies and it could be 15, but my mom could make a batch of cookies and maybe her recipe is 25, right? We don't know. So does it make sense to just add 2/5 plus 3/10 and that's going to tell us how many eggs hatched? No, right? It doesn't make sense. We can't use that expression to solve this problem. So again, I want you to be using those complete sentences. No, because, blank, 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 using those math terms. No, because here are the things that we don't know. Or no, because it's asking for the total eggs and we don't know how many eggs are in the batch. Or no, because if I add, I'm just going to get a fraction, right? But I still don't know how many eggs we started with, right? I was not given enough information and I would not use addition to solve this problem. Okay. I really liked this work for today, actually, because a lot of times we have to focus on solving problems, but sometimes we don't spend enough time. And I don't mean like in class or whatever. I just mean in general, like students often, we jump right in, we want to solve the problem, but we don't actually always take enough time to think, okay, does it actually make sense to add? Does it make sense to subtract? Does it make sense to multiply? What should I be doing here? And we really have to start thinking about that, right? That's what makes, lifelong learners, is being able to sit and really think, okay, how can I solve this problem? And instead of just jumping right in and saying, oh yeah, adding makes sense. I see two fractions, I'm going to add them together. Okay. So down to our exit ticket. Mr. Neville Ice Guy, that's random. Mr. Neville Ice Guy mixed 12 3/5 gallons of chili for a party. Okay. If 7 3/4 gallons of chili were mild and the rest was extra spicy, how much extra spicy chili did Mr. Ice Guy make? Okay. So I know that we started with, we started with 12 3/5 gallons of chili, right? That was our total. I know that 7 3/4 were mild. M for mild, or just mild, if that's better. And the rest was extra spicy, right? This is the spicy part. I have no idea how much spicy chili is. There is. Okay. I want to know how much extra spicy chili did Mr. Ice Guy make? Okay. So I can see that I have a total and I have a part. All right. I know that when I have a total and a part, a lot of times I'm going to either be dividing or subtracting. Division doesn't make sense here, right? I don't see anything about equal groups or putting it into, or each group, each batch was this much. How many batches can I make, right? I don't see any of that. So I see that I want to find the difference, right? He started with 12 3/5. And then he made some that was mild. And now we want to know how much is left. The remaining is spicy, so how much is extra spicy? Okay. So now I'm going to solve this. All right. So you can solve this in whichever way makes sense for you. If you want to draw a visual representation, if you want to draw a number line, something like that, you totally can. If you want to, again, use those tape diagrams kind of like we did in our Fluency, you can. And if you want to solve using an equation expression, you can, all right? As long as you're showing your work and I can see what you're doing. So I'm going to solve using the equation. So I'm going to say, okay, the first thing I do when I'm subtracting mixed numbers, right, is I subtract the whole numbers. So I have 12 minus 7, and that's going to give me 5 3/5 minus 3/4. Okay? Next, I know that I need to take my mixed number and I need to convert it into a fraction greater than 1. So I'm going to use that zigzag method. So 5 times 5 is 25, and then 25 plus 3 is 28. So now I have 28 fifths minus 3/4. Okay? So now I'm going to say, all right, what I need to find my least common multiple. What is the least common multiple between 5 and 4? All right, and I know that I'm going to get 20. Okay? Now I'm going to use that multiplication. 5 times what gives me 20? 5 times 4. And whatever I do the bottom, I have to do up top. 28 times 4. Now, I don't know that off the top of my head, so I'm going to come over here and set it up. 4 times 8 is 32. 4 times 2 is 8. 9, 10, 11. All right, so I get 112. Then I'm going to do the same thing here. 4 times what gives me 20? 4 times 5. And 3 times 5 is 15. All right, so now I'm subtracting 112 20ths minus 15 20ths. All right, so if you don't know what 112 minus 15 is off the top of your head, that's also okay. Just come subtract here. All right. 7. This becomes a 10. All right, I'm going to get 97. So I'm going to move this up here just so I have more room. So I have 97 20ths. All right. So now I need to put this into a mixed number. I'm going to think, okay, how many times does 20 go into 97? So I'm going to count by 20. So 20, 40, 60, 80. All right, if I go one more, it's 100, so that's too much. So I can see it goes in 1, 2, 3, 4 times. And that got me to 80, right? So now how much do I have left over from 80 to 97? All right, that's going to be 17. So I have 4 and 17 20ths of extra spicy chili. Okay, so then of course you would write this in a statement. The question was, how much extra spicy chili did Mr. Ice Guy make? Mr. Ice Guy made 4 and 17 20ths gallons of extra spicy chili. Okay. All right, so that is it for today. I will be back tomorrow with the last day of week 3. I am still trying to figure out with DCPS what exactly the strategy is to get you your next packet of work, especially if you don't have access to that on a computer or anything. So stay tuned. I'll be back with more information soon. All right. Please reach out if you have any questions, and don't forget to send me pictures of your work. All right.